A very good afternoon to all of you. My name is Shogato Pal, and from ICAT and Aspire, I welcome all of you for today's webinar on design for Six Sigma for automotive industries. We have Mr. Suresh Mangavati is a guest speaker who is having 35 years plus experience in the engineering and quality domain in the automotive industry, both tier 1 as well as OEMs. And we had speakers announced as Dr. Madhusudan Joshi, who is the DGM ICAT, but he has to go for a meeting at Ministry. So in place of Madhusudan, we have Mr. Adesh Chauhan, who is heading our CAD-CE lab. So we'll start with his talk, and then followed by, we'll go to the presentation by Suresh. Okay, so with this brief, Adesh is...
Yes, Saugata. Thank you, Saugata.
He's AGM and heading the CAD-CE lab, and having almost 25 years experience working in the company like General Electric, Caterpillar, and he's with ICAT since 2018. Okay, his area of interest is virtual design as well as the physical correlation of the virtual world with the physical worlds. So with this word, I'll just start to Adesh to give the initial talk from ICAT. Then we'll go to Suresh. Over to you, Adesh.
Thank you, Saugata. Good afternoon to all. On behalf of ICAT, Mane sir, thanks for joining webinar for today, Design for Six Sigma for Automotive Design. We have us today subject matter expert like what Saugata said, Mr. Suresh Mangavati, who is having more than 35 years experience working in a quality domain for automotive industries. Before he gives his talk on DFSS, let me give you some background on for today's initiative. ICAT is a premium R&D organization established in 2006 under NATRI project of Department of Heavy Industries, Government of India. ICAT is giving service to the auto industries for homologation, certification, development testings, and regulatory framework. Apart from this, we provide development testing for automotive, non-automotive industries like aviation, railway, defense, like that. In ICAT, we have around 600 plus people involved in state-of-art laboratories working like powertrain, electrical electronics, EMC, component crash, fatigue, NVH, vehicle dynamics, and simulation. In year 2020, Ministry of Heavy Industry supported the launch of 6 technology platform to support the collaborative research involving industry and academia. In that scheme, ICAT launched Aspire portal to support the automotive industries. With this initiative, we are holding various knowledge sharing sessions and conferences and conducting the internship program for engineering students and fresh graduates. In continuation to this journey of knowledge sharing, we have the topic today on DFSS for the automotive industries. So DFSS is a design for Six Sigma. That's short form is DFSS. This is a branch, you can say, of a Six Sigma methodology, which is primarily used for the design aspect of the product. So DFSS is a systematically data-driven approach used to design the product, services, and process with exceptional quality and minimal defects. It focuses on achieving excellence in design phase of product by reducing the variabilities and focusing on the customer requirement. I hope participants from today's webinar will get an overall concept of DFSS and will be useful in practical application for their professional assignment and careers. Thank you very much.
Thank you, Adesh, for your words and setting the stage. Uh, Now we'll move to Suresh. Suresh, as I said, is having a vast experience for supporting the design improvement, process quality, plant engineering, and both working in multinationals, OEMs, tier one suppliers, as well as the service providing companies. So recently, he superannuated from TCS, and we are all gathered to hear the wisdom and experience which Suresh has gathered. And he has trained, I think, more than 500 engineers and more than 200 hours of lectures on DFSS. So with that, I'll request Suresh to take over. And for participants in this webinar, okay, you can put your questions, queries in the chat box or Q&A sections. Okay, for proper conducting the webinar, everybody, all of you will not able to speak, but however, you can put your questions in the chat box, and I'll be there to facilitate it to bridge the gap between expert and you, so that you get the answer of your questions and answers. With that, Suresh, over to you.
Okay. Thanks, Saugata. Thanks, Adesh, for the nice words. And let me start this thing. Before that, Saugata, it is showing chart is only available during the meeting. If I click on the chart, just look into that. With that, I will share my screen. You can see my screen, right?
Yes, we can.
Okay. Thank you. And today's topic, overview of DFSS. The long form for DFSS is the design for Six Sigma. Very interesting topic, especially, in the third phase, analysis phase. You will really love to know that, what are the different creativity techniques we have to come out with a beautiful design, or which meets all the requirements. So I will be sharing you a lot of my experience, and make I guarantee you that by the end of today, definitely you will get to add value to yourself, to more know on design for Six Sigma. And this is my personal email ID and mobile number. And with this, let me start. First, let me introduce myself. As Adesh told and as Saugata told, I have 38 years of quality and engineering experience. Basically, I am a mechanical engineering graduate. Then I did my MTech and in quality management. And the companies I have worked for is General Motors, iShare Motors, Tata Motors, Escape Bearings, Tata Consultancy Service, and General Electric. So if you see, excluding the last one, I am throughout my career, I am with automotive engineering, and in two departments mainly, product engineering and quality. So those are my key areas of working. And coming to Six Sigma expertise, I am master black belt in Six Sigma, and then I'm a trainer, a mentor, coach. Hundreds of projects I have coached in Six Sigma, and I am also lead auditor for many quality management systems. like ISO 9001, ISO TS 16949, which is for automotive industry, ISO 17025, that is, test lab management required again for, automotive, and also ISO 13485, which is for, medical devices. So basically, I'm a quality guy, and I was MR in, most of my companies where I have worked in. And presently, I'm doing consultancy for Six Sigma, supply chain management, quality management system, basically, on quality in engineering. Okay. So with that, my introduction, and on my family front, major my responsibilities are done. I have my daughter and son, both are married already, and already I have a grandson as well. So that's a quick on my, personal introduction, and let's directly jump to the today's topic. Okay, before doing, directly going into the slides, I usually, do some icebreaker just to bring everyone, on same page. So you can see a warplane here. Okay, and this is, German. And this warplane is from, World War II. Okay, somewhere in 1945 to 1915, in that period. And there was, a problem. They started facing a problem. Germany started facing the problem, and the problem was given to scientists to resolve. And what the problem was, you can see the windshield here. The windshield, what used to happen is, if a bullet hits the windshield, okay, the whole windshield was made of full of glass. And because of that, when the bullet hits here, the whole windshield collapses. Okay, no glass, nothing is, windshield is available. And because of that, what happens? The plane crash and the pilot also dies. Okay, so a huge loss was, Germany getting, and the German commanders gave this issue to scientists to solve that. And lot of quality tools and techniques, whether it is FMEA, whether it is quality function deployment, so many things, started developing during, World War II itself, after World War II. Maybe the names, exactly names was given later. And this was also, I can relate, how they solved using a Six Sigma methodology here, DFSS methodology itself. What they did, that windshield, instead of making a full glass, they made windshield with the small pieces joined together and two laminated sheets on the front and back of the glass. The bonding, or, the gumming of, these small pieces was so beautiful that in bare eyes, you cannot make it out. And now the windshield is replaced with this technology. And now what happens? When the flight, the plane goes for fighting and a bullet hits windshield. Let's say, consider a bullet hits, and now the whole windshield will not collapse. Instead of that, what happens? One piece where the bullet has hit, that will be gone, and a hole will be made into the windshield. And it has got sufficient time for the pilot and the plane to come back to its own airbase and save the, plane as well as the pilot. A beautiful solution. And it was during the World War, Germany invented this one. And today's automotive, today's windshield of your car, it is made of the same technology. You just see on the road when, there is some, the car is hit, head on with something, and, the glass pieces have fallen on the road. You can see that, they are small pieces joined with the two layers of lamination, front and the top. So that's how the windshield design was changed from full glass to small pieces joining together. And the bonding and the technology, the process used for bonding was so great that, you can't see with the bare eyes. And, there is a laminated sheet on front and back of the windshield as well. So beautiful, methodology. And, one of the things, contribution is from DFSS, Design for Six Sigma. And they didn't call, at that time it is, Six Sigma and all, because Six Sigma name directly came later, somewhere in 1970s, 80s period. But in that period itself, that type of thinking. And even a TRIDGE, I'm bringing a new word to you. TRIDGE is a inventive problem solving technique. Okay. And what I told you is also a part of TRIDGE. And TRIDGE is one of the tools used in Six Sigma, especially in the analyze phase. When we go to analyze phase, we'll talk about that. Okay. This is contents for today. I will, start introduction to Six Sigma overview. And Six Sigma is always, as Adesh was mentioning, it is a structured process. And this is a structured process. It has got 5 phases. First phase is define, second is measure, third is analyze, next is design, next is verify. Any DFSS project which is taken will go through these 5 phases. Okay, this is the commonly used, structured process across industries, but some companies, they also follow IDDOV, which is same as a DMADV only, but name different and a little bit here and there. But commonly used nomenclature for DFSS is DMADV methodology: define, measure, analyze, design, and verify. I will go through each of the phases. What do you mean by that phase, and what tools and techniques are being used in this phases? I'll talk about that. And at the end, I'm going to show you one of the sample DFSS project. Imagine tomorrow you are going to do a DFSS project, what you are required to present in terms of DMADV. So this is a closed project I am showing you, and what they have done in define, what they have done in measure, analyze, all these things I know I will cover over there. Okay. So with these contents in mind, let's start our training. The first topic is Introduction to Six Sigma. And here I will be talking about what is Six Sigma and statistical objective of Six Sigma. This is very important. The Six Sigma, the name itself, right? Sigma. Sigma is a standard deviation, right? And the question comes, why 6? Why not 5? Why not 4? Why not 7? Okay, we'll talk about all those things. So what is a technical or statistical objective of Six Sigma? We'll talk about that. And what is, DFSS in Six Sigma, because there are 2 methodologies in Six Sigma. One is DMAIC, that is called as a DMAC. Some people call it as an OPEX, operational excellence, also they call. Basically DMAIC, and another is DMADV. But today's my topic is on DMADV. Okay, DMADV is also called as the design for Six Sigma, right? And the another approach is DMAIC. I will talk about these two and what is the difference between those two and when to use which methodology. I will be talking about that as well for you today. Okay. I got this, beautiful saying from Charles Kettering, one of the, initial, engineers in General Motors. Okay. Beautiful sentence he has told: a problem well defined is a problem half solved. Beautiful sentence, a lot of meaning in that. The point is, if you know the problem, or if you can exactly define the problem, half a problem is solved. We struggle, in defining the problem itself. For example, many times we say that, my customers doesn't pay me on time. Yes, I'm saying a sentence, but is it a good problem statement? No, it is not at all a good problem statement in terms of Six Sigma. And what should be the right problem statement for the same problem, I will cover in the later slides. Just I'm telling, my customers are not paying on time. That is a problem, but that is not a problem statement. Okay, if you start the problem solving with that statement, you will never reach to your solution. So that's why maybe Kettering mentioned that a problem well defined is a problem half solved. Half a problem is solved. He's a great engineer from General Motors. I got this sentence from him. I thought I'll present it to you. Okay, need for implementing Six Sigma. I'll tell you a case study. You might be already experienced this, or you may be experiencing in your future. Imagine you have got an issue or some problem is there, and you thought you fixed it. Okay. Great. And everyone is happy. Wow. Even awards recognition, everything is done. Time passes. Again, the same issue returns. I tell you, this is possible in this world. And why is that? I had solved the problem, but after some time, the problem returns. So we don't have a robust problem solving methodology. Or one more, important phase in Six Sigma is sustain. So you solve the problem, actions, and you cannot sustain the actions. So if you cannot sustain or control, the one more word for quality in that is control or sustain. If you don't do, the problem returns. So what you need? You need a robust problem solving methodology, and that's what we are talking today, Six Sigma. Okay, on the lighter side, on the right side, usually how you fix the problems, I'm just on the lighter side, I'm mentioning, try something and wait. Okay, अरे यार, you have got a problem and कुछ करो, देखेंगे, solve होएगा. So let's try something and wait. Do what has been done in the past. Oh, I remember, similar problem had come in that model or that, variant. Let's use the same thing over and to solve this. That's one way. Do what experts say. Boss, I have expert in brakes, and just ask him how to solve this issue related to brakes. So experts, you go to experts or have a meeting and vote. Consensus method. So all related people you met and then you voted which is the best solution and you went out. You never analyzed the problem in depth. Or, usually that is a habit, right? Blame the operator or engineer. Okay. Because of this, because of him, this problem happened and all. So all these are not good solutions. Blame the supplier or don't tell anyone. Hide the evidence itself. Okay. You have a problem. Don't tell everyone unless it is affecting anyone. If all fails, just do something. So this is typically, we think of, solving the problem, but this is not the way. And Six Sigma is the way. We'll tell you, we'll show you how Six Sigma is, important and it is robust. Okay. The new word is coming here now, robust. What do you mean by robustness? There are so many quality words, right? Quality, robustness, and then, many words are reliability, durability, so many words are there. But I am using the word robust here. What do you mean by robust? Robust means your design should be insensitive to the noises. Noise, Noise. This is not audible noise. The noise in the system means the factors which are not in your control. Your design should work in presence of uncontrollable parameters. That is DFSS. Robustness. Robustness means, I repeat, it is your design should be insensitive or your design should work in presence of noises. Noises are uncontrollable parameters. For example, temperature and humidity and even customer usage is also noise. My design should work on that. On the lighter side, again, I cannot tell that, boss, imagine I am, manufacturer of a pump. Okay, don't take this pump to Gurgaon. The pump will not start. I can put a beautiful work instructions inside. No. People should in Gurgaon also should use. People in Shimla also should use your output should remain same, irrespective of whether you are using in Gurgaon, whether you are using in Shimla. That is called as robustness. And how robustness comes into picture is through DFSS, design for Six Sigma. How DFSS is different from other problem solving techniques. You have a lot of problem solving techniques. You might have heard about that, like 8D. One of the famous problem solving technique, and originally it was used by Ford. You have 8D, you have REDX, General Motors uses REDX methodology, root cause analysis methodology, and other companies uses PDCA, simple, plan, do, check, act. There are so many, problem solving techniques you might have come across, but why DFSS is more important? Because it proves that in presence of noises, your design gives the same output. That is, your design is robust. So that's a word called as robustness. And we measure, there is a method to measure the robustness of your product. For example, you have two parts. Okay, both are robust. Which is more robust than other? What is the metric? How to measure? There is a way. We measure this in optimized space. So robustness is very important. And coming to the history of Six Sigma, Motorola was the first to implement Six Sigma. Okay, and somewhere in 87, and then you can see all these countries: Texas, IBM, ABB, Allied Signals, Honeywell, GE, General Electric was the one which used Jack Welch, the managing director of General Electric, made Six Sigma to such a level that they got a lot of benefits from Six Sigma, and they took Six Sigma to the next level. Even though Motorola invented Six Sigma, GE name is always attached to Six Sigma. And I worked in GE for 2 years, where I became the black belt. The most important thing in GE is, if you want to continue in GE, you have to become green belt before 1 year of your joining. Your probationary period is 1 year, and if you don't become green belt in Six Sigma, you are out. That is GE, General Electric. Okay, American Express, Bank of America, Whirlpool, Sony, so many companies have implemented. And in India, many banks, HDFC, ICICI, Tata Steel, VSNL, Tata Motors, Genpact, GM in India, Lear Corporation, many companies have, implemented Six Sigma and got, benefit out of that. Six Sigma philosophy. Six Sigma, as Adesh mentioned in one word. I don't know how many you caught that in the beginning. Variation, variability. That's what your Six Sigma methodology reduces, and that's Six Sigma philosophy. You can see on the bell curve over there. There is a standard deviation and your defects. You have upper and lower specification limits, and in the middle you have the mean target. So the whole philosophy of Six Sigma is to reduce the standard deviation or reduce the variation. But for that, you need a lot of things. So this is my favorite, paragraph, and I will just read for you. We don't know what we don't know. This is possible. Huh? We don't know what we don't know. We can't do what we don't know. We won't know until we measure. So the whole Six Sigma is about measurement. You need evidence. And next sentence is, we don't measure what we don't value, and we don't value what we don't measure. A little bit confusing, but nice sentences. And the meaning of this thing is, boss, we need data. We need evidence to prove anything. I need evidence. I believe in God, no doubt about it. But from Six Sigma point of view, show me the evidence. That's a word. Let me give the example of judge. Judge. What he does in the court. He needs evidence. Unless you have an evidence, otherwise he is not a criminal. That's what it is. And Six Sigma philosophy is also that. The whole philosophy is reduce the variation, and you need to measure, and you need to give the evidence. Right? Okay, just by asking the expert and changing that, it won't help. You are going to miss any decisions taking in Six Sigma is based on evidence. That's important in overview of DFSS. Okay, here is a paragraph. Usually if it is a physical, classroom training, I would have given printed sheets of this. And even, I tell you that, just count a number of F alphabet in the below paragraph. I will give you 1 minute. You keep it with you. Maybe in the chat box you mention how many F's you found in this paragraph. So it is 2:29. I will give you 1 minute. Just a paragraph. Count number of F's in this paragraph. I hope everyone is working on that. And you can note down in your notebook or this thing. And I wish you publish in the chat box how much answer you got, how many Fs you got.
Pushparaj has answered 21.
कितना आया?
The answers varies from 21 to 26.
Oh, okay. Both are wrong, Saugata.
Okay, highest is 31 so far.
Oh, is it?
Rajesh. Yes, 32 from Manikandan. Ashutosh Mishra, 33. So his number is.
Okay, shall we stop now? Okay. See, the intention of this exercise is to tell you that variation is common, sir. And now tell me, all are engineers, all are experts in English, and a simple problem, right? Count a number of Fs, but still we don't get a single answer. I tell you, this is 100% inspection you did. I tell you, if I give you 200% inspection, another one more time if I give, then also I don't get one answer. Why? Same guy again, counting. Everybody is in front of your, paragraph, and all are experts, all are English experts, and I'm just telling count number of Fs. Still we can't get a single answer. This is the same thing, sir. Even in a factory, I tell you in the shop floor, I will give you one turning diameter 10 plus or minus 10 microns. Okay, just I'm telling you diameter 10. I will give you a bar to turn in the lathe. Same operator, same instruments, same tools, same environment, everything same. I will give him 10 pieces to turn, and the specification is dia 10 plus or minus 10 microns. Now tell me whether the operator can turn all the 10 parts exactly 10.00. All the 10 parts. Answer is no. Answer is no. He cannot. So this is called as common variation. In statistics, there is common cause variation, special cause variation. Common cause variation will be there, and it has to be there. Sir, you consider your life. Tell me whose life is without variation. Ups and downs are there in life also, sir. On the lighter side, I will tell you one thing. Ratan Tata once told, in hospital, a patient is under ECG machine, and you will be seeing in the film also, right? The line is going up and down in the ECG machine. Okay, and what Ratan Tata told that that is common cause variation, and it has to be there. Imagine instead of the line going up and down, it became straight line. What is the meaning of that? Patient is gone. Okay, on the lighter side, don't compare directly with your statistics, but the point is variation is common, sir. So that is called as common cause variation. And in between anything which happens, that is called a special cause variation. The intention of this exercise is to tell you that variation is common to certain extent, and that's how when you put your SPC charts, statistical process control charts, X bar R chart for an example, there will be variation, no, but you have two limits there, one specification limits and then control limits. As long as all the points are in control limits, your process is in control, but variation is allowed there also. You cannot manufacture, I told you, 10.00 dot all the 10 parts, same operator, same tools, same instruments, same environment. My point is just to make you that Boss, variation is common. Little bit of motivation talk. Even it applies to your, our life also. Boss, never go get bogged or this thing. Arey yaar, sab mere ko ho raha hai. Even, always I am getting hit. No, that is a common cause variation. And, tomorrow again is a fresh day. Again, something different will happen. And maybe that for your good thing, these things are happening. At that time, don't feel bogged. And the sentence is variation is common. Okay. With that, two words usually, we get in statistics. Accurate and precise. What is the difference between accuracy and precision? It strikes, So the first picture on the left side, this is called as accurate but not precise. But here, all these dots are at one place, but they are away from the target. Imagine this is the mean, this is the target. This is the mean. You are away from this thing, but variation among them is slow, less. So here you can see mean is centered. If I take the mean of this data points, mean is on the target. Imagine dia 10. If I take mean of all these data points, it is coming dia 10. So mean is centered, but large variation. Imagine this is your specification limits. You are using full specifications. Imagine that 10 plus or 10 microns your specification limit. So your limits are coming 10.09, 10.08, 10.07. But if I take mean of all, it is coming in the diet 10 exactly. So that is called as accurate, but not precise. Not precise means you have high variation. But here is the other way around. Variation is very less, but the mean is shifted from the target, sir. So this is dia 10, but all your manufacturers, 10 parts or 5 parts you are manufacturing are, mean if I take it is 10.05, but all are within plus or minus 1 micron. But the mean itself is shifted. But in Six Sigma, as a DFSS engineer, what you need? Accuracy or precision? I want both. And that's what Six Sigma does for you. It ensures that you are, accurate and you are precise also. So that's what I know. I just want to tell you. Okay, a few information on because we're going to overview. There is ISO standard on Six Sigma. There are some two parts. DMAC basically they have covered here. And 13053 and tools and techniques here. And one more, competencies for key personnel and their organizations for Six Sigma. It is ISO 18404. Otherwise, ISO standard for Six Sigma is 13053, 2011 version. Just for your information, ISO standard on Six Sigma. And now coming the question, what is Six Sigma? Because there is a, word Sigma, right? So sigma is a Greek alphabet, right? So in general, sigma is a standard deviation, and how standard deviation is calculated? Square root of variation is your standard deviation, right? Square root of v is your sigma. So it is a degree of variation, and we want variation to be reduced. And it is a level of defects. So you measure, in Six Sigma, the Six Sigma itself means 3.4 defects per million opportunities. If anybody says that his product quality is Six Sigma, means only 3.4 defects are coming in 10 lakh parts being produced. Imagine the shape, shaft I was telling you. If you produce 10,000 shafts, 10 lakh parts, only 3 defects will come in that. Look at that. The whatever, DPMO they call, you can say PPM also, parts per million or defects per million opportunities, both are same. So just 3 ppm. In 10 lakh parts, only 3 defects will come. That is the measure of, Six Sigma, right? And there is also, 5 Sigma. So imagine, you are getting around 230 defects in 10 lakh parts. Then you are at 5 Sigma. And 6,210 4 Sigma. So let's concentrate last 3. So if anybody says he is at 4 Sigma quality, means his defect rate is 6,210. And I tell you, most of the processes are at 4 Sigma. That means 6,210, defects per million opportunities. Reaching Six Sigma is not easy. It's very tough. If you are from the shop floor, you understand how much, improvement, exponential improvement is required from reaching 4 Sigma to 6 Sigma, right? Just 3 defects over here. And if somebody says, on lighter side again, I'm 99% confident that, this is the answer or this is how it is. If he says he is at 99% confident, that means he is at 4 Sigma. His confidence level is at 4 Sigma. So 4 Sigma means 99.3% accuracy, whereas 6 Sigma means 99.9997. Look at that. Actually, 666 it comes here. So that is the percentage of accuracy of the yield. So Six Sigma as a measure of defect rate is 3.4 sigmas. Okay. And the business definition of Six Sigma is a method reducing the variability and improve customer satisfaction. And one word is there in Six Sigma in every phase is if customer word is not there, if evidence word is not there, then it is not Six Sigma. 2 words throughout every slides on Six Sigma, every topics of Sigma is customer and evidence. And other, these methodologies are common, like, customer satisfaction, data-driven decision. This I told you. We need data. We need proof. We need evidence in Six Sigma. Without which, we cannot close any, phases of your project. Reducing variation, disciplined approach, prediction of product quality, and a communication language. So communication language, I tell you, I was working in General Electric. Whole GE works on, Six Sigma, whether you are from production, whether you are from design, whether you are from HR, whether you are from finance, irrespective of your function, everybody talks in Six Sigma language. What is Six Sigma language? It is a defect rate, yeah. They are measuring in terms of, DPMO. So 3.4 DPMO means 6 Sigma. For example, everybody has got process, right? Whether it is a finance or HR. HR, let us take HR, a hiring process. Okay, you can measure the process defect rate, right? So for example, in HR process, your target is once you receive the request in 3 months, the guy should be on board. That's a target. And how many you missed in last 6 months? Then you, calculate your DPMO. So the whole company talks on, Six Sigma. That should be the common language. Don't think that Six Sigma is only for shop floor. Six Sigma is for everyone, whether it is a service, whether it is a production, whether it is a design. Everybody is, can be under Six Sigma. That's, greatness of Six Sigma. And everyone can talk in the Sigma languages. And I tell you, from design point of view, once you are designing your part, you can predict what will be the quality of my part. Imagine you are designing a fender, right? You can predict what will be my Six Sigma quality before production starts. To that level, you can calculate, and a lot of statistical tools are being used in Six Sigma. So Six Sigma is, really a great methodology, and it talks about, DPMO. And imagine, and I will tell you the seriousness of this. Six Sigma means 3.4 defect. Imagine you are going to go to your native, Delhi, for example. Okay. And then you looked into, there was a vacation coming and decided you want to go with family, and you selected, say, Air India. Just I'm taking an example. Huh? You selected Air India and then you went to the airport to board the flight. And there they have mentioned that today their process of flying is at 4 Sigma. What it means? 6,210 planes are going to crash out of 10 lakhs. That's the quality level they are working on today. 4 Sigma level. Now you understood how much important it is Six Sigma. Anything for your health. Imagine, ultrasound scanning machine. Okay, you took your, wife for, ultrasound scanning. You are expecting a baby, and the machine is directly used on the human body, right? And that guy says, the quality of that ultrasound scanning machine is 4 sigma. I'm just correlating and making you aware that, how much is 6 sigma, importance of 6 sigma. And next to 6 sigma is ZD, zero defect. That's what, no defect, irrespective of, this thing. And that's where, you should plan, but it is not tough. It is tough. It is not easy. Okay. I think you got the glimpse of what is 6 sigma and what is a glimpse of, what do you mean by DPMO and how much, is for 6 sigma. So blindly you can say 6 sigma quality means your defect rate is, 3.4 ppm, or in terms of 6 sigma, they use DPMO. Okay, a little bit, on statistics. That's what we can, also tell during our, training. That is, what is statistics? Statistics, it is a science. Usually, we consider statistics means collect the data. You go to any company, they have tons of data. Tell me who doesn't have the data? Every department has tons of data, but they're sleeping on that. It is not statistics. What is statistics means you collect the data, analyze the data, present the data, utilize the facts, and then draw conclusions and make decisions. Unless the last 2 points are done, then you are not following the statistical method. The statistical method is not only collecting the data. It is collecting, analyzing, presenting, doing conclusion and making decisions. If you don't make decisions out of that, then it is waste of collecting the data. If you don't conclude what the data says, you can't. It is not known as a statistical way. Otherwise, like everyone says, hey, we have everything data. All data is there. So what data? You are just sleeping on those data. You need to conclude. You need to make a decision. Okay. There are different, tools in statistics to, draw conclusion and make decisions and all. So one of the tool used in statistics is called as Minitab. Minitab is a statistical analysis software which helps you analyze the data. Your collection data is your job. Once you collect the data, feed it to Minitab. It analyzes for you, it utilizes, it draws a conclusion and then gives the decision. For example, you collected the cycle time data. Let's take an example. Now you collected the cycle time data and then you fed it into Minitab. And then it analyzes, it takes the Pareto analysis. You can do all statistical analysis in, Minitab. The higher end, statistical analysis like regression analysis. I'm just taking an example. Regression analysis you can do. Hypothesis testing you can do in statistics. What is hypothesis testing? You have to assume, you have to, hypothesize and then prove, right? For example, in the shop floor, you have done some improvement, process improvement you have done. Whether is it a real process improvement has happened, yes or no, you can prove statistically. Yeah, I have improved, this thing. Then let's collect the data. Let before and after. You collect the data before, you collect the data after, and then statistically you can prove that you have done a good job of improving the process. Process improvement has happened. That brings one more point to me is, you may be knowing about process capability, right? So you calculate the process capability. Maybe, if for automotive, tier 1 suppliers or automotive itself, you know that it is to collect the data and then, you calculate the process capability, the capability of your process, and it is measured in terms of CP/CPK and PP/PPK. CP/CPK is for ongoing process capability. PP/PPK is, one time, preliminary process capability. Now, if I ask, what is the relation between process capability and Six Sigma? I tell you, 2 process capability is Six Sigma. If your quality or your process is at 6 sigma, That means your process capability is 2.0. CP/CPK requirement as per PPAP, production part approval process, is 1.33. But you need to achieve 2 sigma, 2 CP/CPK. It's very tough. The guys who have worked on PPAP, the guys who are worked in the quality, you will understand to how difficult it is to reach 1.33 CP/CPK. But you have to reach 2.0 to reach a Six Sigma quality. That's a comparison between your Six Sigma and process capability, just as an information. Okay, data types, because we need a lot of data, and we need because Six Sigma is statistics, right? So a lot of statistics, and you need to be master in to become a black belt in Six Sigma. And in GE, I told you, even for green belt exam, there will be an exam after the requirement says you have to go through training. It is a 5 days training, Six Sigma green belt training, 5 days. I used to conduct for General Motors, 5 days. The morning it starts 8 hours a day for 5 consecutive days. Morning you start your training, Friday it ends. 5 days green belt training, and after that you have to take a project and complete all the 5 phases, DMA, DV, get it closed, and then take a exam, green belt exam. Pass the exam, then you are a green belt. I tell you, in GE, it is hell to pass that exam. So much of statistics, man. Usually engineers hate statistics. That's given. They don't like statistics. Too many reasons. One is difficult to understand. Another thing is these statisticians, these are very knowledgeable people. What they can't, talk in a layman language. Okay, hypothesis setting, regression analysis, and all. And this is too much, for engineers. So engineers hate statistics. But to pass a green belt exam, you need to go through all those things, and you need to be a master in statistics. What I'm giving here is just a data, and the basics of statistics, that is mean, mode, median, standard deviation, range, that much only. Okay, 3 types of data always: qualitative data, quantitative data, ordinal data. These two, I think you are aware. You may not be knowing ordinal data. Quantitative data is numerical data. For example, all the people, some 40 people are there in training. I measure everybody's height. That is quantitative data. The qualitative data is how many males are there, how many females are there in that. Sag, adult, hood, roof, all those things I have given an example here. That is a qualitative data. This is quantitative data. Ordinal data. Ordinal data is coming from your survey. Imagine you conduct a customer satisfaction survey and customer rates you from 1 to 5. 5 is the best and 1 is the least. So that type of data collected is called as ordinal data. So 3 types of data. I have just shown you, scratches and dents, in when you do visual inspection, right? In General Motors terms, we used to call GCA, but basically it's a visual inspection, like how many scratches and dents he has found, and this is the inspector's report, the thickness of the sheet metal seals, and you can just like check sheet what we use, right? So that's basics of statistics. I just want to give you. There are 3 types of projects in Six Sigma: reactive projects, transactional project, proactive projects. Reactive projects means problem has already happened. You are solving. Problem has already happened. Like warranty. Warranty, what is warranty? Warranty means your problem has already happened. Fixing the, identifying the root cause analysis and fixing that is called as a reactive projects. And Six Sigma has got 2 projects, types of methodology. I said DMAIC and DMADV. DMAIC falls for reactive projects. Already the problem has happened. You use DMAIC, manufacturing products, components, and I will come middle in the later. Proactive, opposite to reactive, is proactive. Problem has not happened. Still you are doing taking a Six Sigma project. For what? to develop new processes, new technologies, new products, and ensure that your design will be robust, your process will be robust, so that once it is released for production, you don't get problems. So that is kind of proactive. So proactive means to stop the occurrence of a problem. I'm using the word English word occurrence. And reactive projects means stop the recurrence of the problem. Reoccurrence, reoccur, it should not happen. So reactive projects are for recurrence, proactive projects for the occurrence. No occurrence is proactive projects. No recurrence is reactive projects. And middle one is a transactional project. Basically, the business problems, scheduling, sourcing, hiring. One of the tools what we use for transactional projects is PDCA we use, and we also use other methodologies like SIPOC. There are so many tools, for transactional projects. Basically, transactional is for the process. You can see reactive and proactive for products and transactional for the process. You want to do a process improvement. And one of the biggest tools used in transactional projects is value stream mapping. You might have heard about VSM, value stream mapping. What is value stream mapping? You map the process as it is. You identify the waste. There are 8 types of waste, right? 7 plus 1. The new waste type is also added now. So you identify what type of waste is there. Remove that waste from your process. You map your new process. So before and after. Okay, so that is type of projects are called as value stream mapping, and they fall under transactional projects. Okay, remember always 3 types of projects. Either if you are solving a problem, in the sense problem has already happened, that is then you are doing a reactive project, you can use DMAIC. And if problem has not happened, but you don't want the problem to happen, so then go for proactive, that is DFSS or DMADV. So the main difference between DMAC and DFSS is this. DMAC is for reactive projects. DMADV or DFSS is for proactive projects. One, this is my favorite slide where, I can tell you that, how complicated, how difficult, each methodology is about. Imagine it is a tree, a mango tree. Let's consider some mangoes are fallen on the ground. Some are low hanging, some are middle, some on the top. The ground fruit. So imagine you go to the tree and to pick the which is on the ground. It doesn't take much. It doesn't need big tools, isn't it? 7 quality basic tools: check sheet, control chart, fishbone. You do all those things and pick it. Low hanging fruits are thoda aapko jump karna padega. Little jump you have to do. And there, we call PDCA, quality circle and all. These are the tools we use, quality tools. Much of the, fruits are there in the middle of the tree. There we need DMAIC, Six Sigma methodology, DMAC, and lean concepts. You might have heard about lean concepts, right? And on boards, Kaizen, Gemba, so many Japanese words you may be aware of. Basically, lean concepts and DMAC is used for the bulk of the fruits in the middle. Top of the fruit is their very sweet fruit. But you are standing here, you can't reach that so easily. To get those things, you need DFSS. So that is a sweet fruit, and you should go for the methodology called as DFSS to get that sweet. So that's a different. You should know that, tools, how much, important that I am explaining you using, harvesting a Six Sigma tree, right? And the fruits. Just a pictorial information, where to use DMADV, where to use DMAC. This is your, in General Motors, they call GVDP, GVDP is, global vehicle manufacturing process. Everybody, even Maruti has got, everyone has got. It is part of, APQP in QS 9000, standard. These are the 5 phases of any product development: research, design, prototype, production, and customer. Okay, your SOP is somewhere here. So if you see the picture, DMADV or DFSS projects are used much earlier in the your vehicle development process, but DMAC comes a little later. Basically, when your production is started. That's why DMAC is both are continuous improvement projects. DMAC is a reactive problem solving technique is a DMAC, but DMADV is, proactive. Problem has not happened. You don't want the problem to happen. You want your design to be robust. Then use DMADV. So DMADV comes in earlier. DMAC comes at later. One important point I have mentioned here. In DMAC, problems are easy to see, but costly to fix. I'll tell you. Because failed part is in your hand. Right? Warranty, I told you, it is a failed part. It is in your hand. You can easily see the problem, but costly to fix. Why? Already toolings are manufactured, toolings are done, your SOP started. So it is costly to fix. Imagine you want to come with a design change, after, SOP is done and tooling has to be changed, and toolings cost very high. More than 1 crore for single tool. A plastic injection molding tool cost you more than 1 crore. But DMADV problems are hard to see. Boss, still we are not started. You are talking about the problems. What is FMEA? FMEA is a tool used in DMADV. FMEA is what? Failure modes and effect analysis. What you do there? You identify the potential failure modes. DFMEA, let's take, DFMEA. You have to identify what type of design failures can happen in my design, take action in advance so that in SOP, you don't get problems. That's DMADV. So problems are hard to see. You have to imagine potential problems, potential failure modes, how my design can fail, how my process can fail, and take action in advance. But easy to fix because still P2 release has not happened. That means your design drawing release has not happened yet. Change करने में कितना time लगेगा? How much time is required to change? In changing diameter 10 to diameter 15 in CAD, 2 minutes, 1 minute, you can change the dimension because still tooling is not done. Still production is not started. So easy to fix but hard to see. That's the main difference between DMAC and DMADV. So this is the picture, where, DMADV and DMAC. I already explained you, in detail. DMADV is called also as DFSS, Design for Six Sigma, and it has got define, measure, analyze, design, and verify. DMADV, where DMAC is define, measure, analyze, improve, and control. Here are the two words here: improve and control. Here, design and verify. Here design word is coming because it is a proactive and you're using DMADV in design, in product design. DMAC, improve and control, is coming because you are solving the problem. So for solving the problem, you use DMAIC. For designing, you use DMADV. So when I say designing, that means design and development and of new products as well as change in the design. Imagine you have released the design. Okay, your product design is released, but you realize that while prototyping, there it needs some design change. So when you go for a design change or when you go for a totally new design, you use Six Sigma DFSS. DFSS means you use these 5 steps methodology: define, measure, analyze, design, and verify. Here DV is there, here IC is there. DV means design and verify, whereas IC is improve and control. Here you define the problem, measure the problem. In the sense, you define what is the problem and you measure how much is the problem. You analyze why the problem is happening. Then you implement the solutions and you control the solutions. That is DMAC in a single language, single line. Define the problem, measure the problem, analyze why the problem is happening, implement the solutions, and control the solutions. So I was telling you in the beginning that, the problems repeat. That should not happen. For that, in Six Sigma, we have an exclusive phase called as control phase. Basically, it is a sustain phase. Sustain what? Sustain the implemented action plan. you monitor. Maybe, go for XBAR chart, you go for different quantity tools and you sustain and you control. Many times we don't close Six Sigma projects depending on, how much, period you want to check for the sustenance. In the sense, for example, you are getting, some scratch issue, okay, on one of the rear view mirrors. Okay. And then you solved using DMAIC. Now this project is in sustain phase, control phase. So how much period you want to wait till you close the project? I want to check next 3 months and then I will close the project. That's fine. So in General Motors terminology, 12 MIS data, 3 MIS data, 6 MIS data means your warranty data. In general it is given 3 months average, 6 months average, 12 months average, that data. So you want to wait for 3 MIS data, means you want to wait for 3 months to see that you don't have problems. That's DMAC. Here both three are same. First you define the problem, then measure. Measure means here problem has not happened. No, here problem has happened. It is very easy. Define, measure, analyze, very easy. But here you define what you want to achieve, and then measure phase. If you want to achieve these goals, what are the functional requirements? What are the functional measures that the output of a define phase is a problem statement. The output of measure phase is functional requirements. You translate the voice of the customers captured in define phase into functional measures. That is called as measure phase. Analyze phase, use all your creativity. Come out with, beautiful concepts. A most interesting phase in DMADV is A phase. And for adults, it is very tough. We'll talk about that little later after the break. Okay. And then comes your design phase. Design phase is simple, sir, as it is your design and development, prototype testing, all those things. So basically, what all you do in design. So design planning you do, design inputs you have got, the design outputs you have got, design controls you have got, design changes you have got. All those things are your, design phase. Basically, design and develop. Design and develop what? The concept what you have derived in earlier phase. That's called as, analyze phase. And last one is verify. Verify that what you had taken as a goal in your define phase is met with evidence. One thing in whole Six Sigma, whether it is a DMAIC, whether it is DMADV, evidence is mandatory. Without evidence, you cannot, further go. So another is process management. Let's not talk about today. It's like I was telling you, transactional projects, So transactional projects come over here. Value stream mapping is, basically we use. Let's start with define phase, right? So these are the 5 phases in Six Sigma, DFSS especially. Design for Six Sigma. You have define phase, you have measure phase, you have analyze phase, design, and verify. So DMADV. These are the 5 phases in DFSS. You see, this is circle. Why this is circle? They would have put it in a straight line also, right? Define, measure, one after the other. They have put it in a circle. Means once you complete the project after verify phase, again next improvement you will go for a define phase. It's a cycle. That's why DMADV is put it in circle. Define, measure, analyze, design, verify. So this is called as a DFSS cycle or circle, whatever it is. So after your project is done, maybe you took 6 months to complete the project. Okay, then take next improvement. Next, this thing again you go into define phase. It's like PDCA. Like PDCA is also a cycle, right? Plan, do, check, act. It is also circle. So that's why it is called as DFSS circle or cycle. So DMADV. So the first phase is called as define phase. In layman language, what is define phase? Define the project. Define the requirements. As simple as that. So define the problem, define the requirements, define what you want to achieve, define the goals and objectives. That is called as define phase. So define phase, these are all the things we do in define phase. One is define project objectives. What are the goals of the projects? What you want to do? Hello? Yeah. Okay. What are the goals and objectives of your project? What you want to achieve in this project? You can give the background. Imagine you are working on brake. Okay, let's take parking brake lever. Okay, you are working on parking brake lever, right? So the parking brake lever, give the background of what you want to achieve in that. Your parking brake lever should be robust enough. It should withstand so many kg force. Okay, because when the vehicle is, on the particular slope, that, when you apply the parking brake, the cable strength of the cable, it is, that is your objective. You want that is to be, achieved. So to achieve that, that is your goal and objective of the project. So that is called as project objectives. Basically, what do you want to achieve is that's you have to define in define phase. Project plan. Project plan is nothing but what you are going to do in. Hello? Anything? Okay. So what you are going to do when you are going to complete define phase, when you are going to complete measure phase, analyze phase, design phase, and verify phase. These are called as, project plan and team roster. In one project, there are different roles. I will explain you. You have project champion, you have project sponsor, you have project coach, you have project leader, and you have project team members. So that is called as the team roster. And if you answer 5W and 1H, 1H is also added here. 5Ws and 1H, your define phase is ready. You answer these Ws. What are Ws? What, when, where, how, all those things are, are called as, Ws and 1H. So if you answer this, your define phase is ready, right? Let's see in detail what are all these things. So the goal of define phase is develop a plan for successfully achieving your objectives. You should have a perfect plan. I was telling you, if, catering said, no, if you don't plan properly. So if you plan properly, 50% of your job is done. This is what is exactly. So you develop a plan for successfully achieving your objectives, develop a plan to be evidence based. You need evidence. Even in the define phase, you need evidence. For example, if you are working on, say, warranty data. So the present warranty is, so much IPTV. Okay, IPTV is the General Motors measurement. PPM, let's take in general. That's the defect rate, right? So presently, your PPM is, say, 500 and you want to reduce it to 200 by doing some design change. Okay, because the process improvement is not possible, you decided that you need a design change and you're using a DFSS methodology. So first you have to give the evidence of 500. 500, how you are getting? Is it last 6 months data? Is it last 3 months data? Where is the evidence? Baselining, we say. Baselining means where are you? What is your present defect rate? So that is required. And then also define the customer needs, what the customer want. The toughest job in anyone is defining the customer needs. I will tell you one thing. Okay. Usually the question comes, boss, who gives me Six Sigma project? Isn't it? So what are the sources, where you can get Six Sigma projects or in the problem statements? One of them is a QFD. QFD is quality function deployment. QFD is a tool, it's a quality tool which is used to translate the voice of the customer into the functional measures. Let me give an example. It is difficult to read, no? Translate voice of the customer into functional, blah, blah, blah. That is a sentence I will give you. For example, JD Power survey, you may be knowing, one of the third-party surveys is done for the new vehicles. Okay, every OEM knows about the JD Power and everybody uses the JD Power data. One of the survey questions to the customer was, let's take front door. Okay, your customer says the front door is difficult to operate. Point number one, you must always understand that customer is not an engineer. He cannot understand your kg force, your weight, your spring force, your torque, nothing he understands. You are an engineer. You have to translate what it means to the customer. Customer voice of the customer is, it is difficult to close the door. So why the customer is telling it is difficult to close the door? That's your job in define phase, to come out with what functional measures are required. For example, why the customer is telling, it is difficult to close the door? Maybe the weight of the door is more. The force required to close the door is more. The force required to open the door is more. Spring force is more. You need more torque to close the door. These are all functional measures or your technical specifications. For the voice, it is difficult to operate your door. Okay. From there you can get different, because there are two competitive assessments in QFD. One is customer competitive assessment, another is technical competitive assessment. For example, when you are designing a particular door of a particular segment of the car, okay, so imagine Maruti. Let's take an example. Maruti is coming out with the new Celerio. Maruti is coming with a new Celerio, and they are looking at the door closure effort. Then what they will do? They will do a clinic. I will talk about clinic a little later, where it is survey. It is done with your competitor vehicles. So every competitor vehicles, it is compared, and then where are you with respect to the force required to close the door from your competitor? And then you can choose a project. Yes, my door weight is more. Yes, my force required to close the door is more. I have an DFSS project there. So that is a source. So QFD is always a great source for selecting a DFSS project. Customer dashboard, scorecard. From there, wherever red items are there, straight away in DFSS project. Surveys and scorecard, straight away wherever red items are there is score. Brainstorming, many times, by brainstorming, you get new projects. Analysis of the critical processes, there you get new projects. Directly discuss with the customer, no, you get new projects. Internal problems, you better know your problems. So you know your problems, take a Six Sigma project for that. And it should be clearly bound, it should be aligned, it should be felt by, this is important. It should be felt by the customer. Whatever improvement you are doing, because Six Sigma is about customer, right? So it should be felt by the customer. Work with other projects, it should be related to your job. If you are working in particular area, you have to take project from there. Then comes your project charter, and project charter is the output of a defined phase. You are in a defined phase. You can see on the top corner here written DMADV. I have highlighted this, means you are in defined phase, first phase. So what all you require in your project charter? What are the objectives and goals of your project? What is the scope of your project? What is the boundary of your project? Project milestones. Project milestones are same, DMADV. These are your project milestones, and budget. Many times, you need money to do a project. Where, for example, you are in the design phase or or analyze phase. You want to do a prototype. You come out with a beautiful design. You came out with a innovative design and concept, and you want to check by doing a prototype. So that is to be given outside. You need money. So you have to present in your defined phase to your management. Boss, I need so much money in my analysis phase, because it is a planning phase. Defined phase is nothing but a project planning. Simple. So you have to plan your DFSS project is the defined phase. Additional thing is, you have to come out with the customer requirements. Define the customer requirement, because it is a defined phase. If you answer these things, your defined phase will be reviewed. What are your objectives and goals? How big is the project? What resources are committed? For example, in this, you may be requiring another person from another department. So this is your team. You need this guy. May not be throughout the project, but only in testing the prototype. You need a guy, so you can ask him. So what are your key deliverables and all those things? It will come over here. So if you answer 5 W's. Why are you doing project? First W, 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 W. Why are you doing your project? Define the value of your customers in your company. If a project does not benefit your company or your customer, don't do that project. As simple as that. I repeat, if it doesn't add value to your company or your customers, useless project, don't do the project. Either it should help you or either it should help your customer or both. Then it is a good project. So why are you doing project? What is the project? Define your scope and objectives. For example, you have to scope, you have to write very clearly, right? What is in scope, what is out of scope. For example, you are working on the right hand side mirror, RH mirror of a car. Mirror, I'm just taking an example. So right hand side mirror, RH mirror is in your scope, LH mirror is out of scope. That's, in scope, in and out. When timeline, when you want to complete, define, measure, analyze everything, and create a team and RASIC. RASIC means, in the team, who is responsible, who is an authority, approving authority, who is supporting, who is informing, consulting. That's RASIC. Define the location of work. What many times what happens, you want to do Six Sigma project at your customer place, or you want to do Six Sigma project in your plant, or you want to do Six Sigma project at your supplier place. So define where you want to do and how. 5W1H, how means this is what it is. Define the problem, measure the problem, analyze the concepts, design the final concept, whatever has been done here, and optimize it, and then verify the optimized design. All are linked. That's why they are in circle. So the output of define phase is taken as input for the measure phase. Output of measure phase is taken as input for the analyze phase. Output of analyze is taken for design. Output of design is taken for verify. This is how it is. So if you know 5W and 1H, your define phase is ready. So this is how, it is not mandatory. There is no template. You can have your own project timeline from Jan, Feb, March, when you want to complete task 1, task 2, whatever it is, or phase 1, phase 2, when you want to complete. It's a project timeline. And you should understand what is the value. So these can be, good, DFSS projects, warranty reduction project, mass reduction project. Okay, you can save some money to the company, So it is not mandatory for every DFSS project to save the money. Many time, it is efficiency improvement projects. So you don't have, cost saving in the project. But if you take a mass reduction project, that's great. So you reduce the mass, you save the money. So mass reduction project, process improvement project, cycle time reduction project, efficiency improvement project, part development project. Then you should see what is present and how much you want to reduce. For example, present warranty is so much, you want to reduce by 50%. Present mass is so much kgs or so many grams, you want to, 30% reduction. You want to improve the cycle time from this to this one. And then you want to improve the efficiency from here to here, and you want to come out with a new project, a robust part development project. That can be one more project. And then, in a problem statement, I was telling you, Charles Kettering, what he said, a well-defined problem is half solved. So let's see, one example is, our customers are not paying their bills on time. This is what I was mentioning you. This is not a good problem statement. It doesn't tell me anything. Instead of this, if I write the same problem statement in this way, that is DFSS. Look at that. The same problem statement. Our customers are not paying their bills on time. Instead of that, what I should write? In 2014, 27% of our customers are late by over 50 days on an average in paying their bills. Data. You have the data. This represents 30% of our outstanding receivables and negatively affecting our operating cash flow. This is the problem statement for this is original. Look at these two differences. Your 50% of the problem is solved here. That's why Kettering said that. So precise, and it should be smart. That's why now we use smart. Smart means specific, measurable, actionable, relevant, time bound. Your problem statement should be smart. It should tell with data. Don't say that, they are not paying bill. How much delay they are doing, how much customers, how it is affecting your, cash flow. all data you give, then it becomes a good problem statement in define phase in DFSS. So this is the objectives. We already talked about that, what you want to improve, what are your goals and objectives, and the scope I was tell you. For example, in door system, let's take, a door system. It has got seals, it has got latches, body structure and door structure. Seals, you are working on seals project. So this is in scope. This is out of scope. If you put a diagram like that in your, project report, how beautiful it is in defined phase. Boss, I'm working only on the seals. Don't ask me about, these things. This is out of scope for my project. There may be another project running on latches and body structure and all, but this project in scope is seals. Okay. So this is what, scoping and boundary, right? And how the output of your, defined phase, looks like in a charter. So it is a charter, project title, and then who is the champion, which department it is going on, what is the current situation, what is your problem statement, what are the expected benefits, okay, how they are aligned to company's strategic objectives. For example, the company has taken, 10%, mass reduction, cost reduction project. This year, company has declared, the MD has declared that, boss, we need to reduce 10% in design department. So we have to take mass reduction. So my project, is it aligned to company's goals? So that is important. What is the process name? Who is the process owner? That's very important. Name, department, role, stakeholder, exception, stakeholder. A stakeholder means, basically internal customers, right? Your milestones, phase. For example, DMADV, when you want to, D, you want to start from when to when, DMAVE. So from to, you can exactly mention about those things. So that is called as define phase. Okay. Then, we'll talk about major phase. I will just brief what is there in major phase, and then, we'll take a, break.
Excuse me, Suresh.
Yeah.
I think it's a great going, and before you go to the next stage of measurement or analysis, but I think we should have 10 minutes break.
Right.
So
Sure.
that everybody can take a bio break or refresh, and then. So right
Sure.
now it is 3:37.
Yeah.
We'll join back exactly after 10 minutes.
Yeah.
So, and participants, I think it's great going. It will be benefit all of us. If you have any questions, you keep that question ready at the end of the session. At 4:30, we'll have half an hour question answer session. So you put your question in the chat box, and certainly Suresh will reply. And if you are not able to give the answer because of the constraint of time or others, we'll get back to you over email. If you can mail the question to me also. Okay. So
Okay.
thank you. We'll have a pause and get back in
Sure.
10 minutes.
Thanks, Saugata. Shall we start?
Yes, Suresh, we are just 10 minutes past the interval, so let's start.
Okay. So now we completed our define phase of DFSS. It has got 5 phases as we earlier told. DMADV, define the problem, measure the problem and come out with the functional measures, analyze and come out with the beautiful concepts, and then for the selected final concept you design and develop and optimize, and whatever design you have developed, verify the design. That is DFSS, DMADV, 5 phases. So we are in the second phase. What we are going to do here is translate voice, customer needs into your functional measures, capture the voice of the customer, house of quality or quality function deployment, from where you can get additional customer needs. We'll talk about these things. Okay. This is what it is. Translating voice or customer needs into functional measures is the goal of this phase, and establish functional measures. So at the end of the project, I should come out with what functional measure will drive my customer satisfying solutions. I tell you simple example. Again, I will take the door example. Customer says, voice of the customer is it difficult to close your door? That is the voice of the customer. What are the functional measures for that? The force required to close the door, the force required to open the door, the hinge force, the torque, the weight of the door. Not only that, sir, position of the handle. Very important. Position of the handle, where you keep your door handle. So these are your functional measures. That is your measure phase. So measure phase is converting voice of the customer into functional measures. Simple. And that we using QFD also, house of quality. This is my favorite sentence. It is exaggerated example. See what happens usually, in typical industries. Every function is a kingdom. Marketing is a kingdom. Product engineering is a kingdom. Quality is a kingdom. Production line is a kingdom. Finance is a king. Everybody kingdom. Everybody has got vice president, directors, these things and all. And nobody wants to talk to each other, only officially. And nobody wants to directly talk to a customer. Production people says, boss, you marketing department job. I don't want to talk to customer. I will manufacture as per drawing given by the design department. Bas ho gaya mera kaam. My job is done. I don't want to talk to customer. Nobody wants to talk to customer. Only in front of the customer is your marketing. So this is what the customer wanted. Just an example. And marketing people went there to meeting with the customer. They understood this is what customer wants. Okay, this is a communication gap. And when they gave to design department, designed like this, they don't know how to fix it. Sales, they ordered like this, and manufacturing people, they manufactured like this. And finally, poor field guys, they have to go and install at a customer place, So finally, they cut the tree and install like this, because this is an exaggerated example. Don't take it as it is. But understanding the voice of the customer and communication is very important. Customer has to be part of your design. Customer has to be part of our APQP. Then only you are going to give the customer satisfying solutions. Don't say that I am in design. I don't need to talk to customer. Whatever marketing has given me a list of requirements, I am designing to meet that. I don't know what customer want. That is your job. You go and ask him. So this type of thinking doesn't work in Six Sigma field. That's why customer evidence is very important and communication is very important. Very simple photograph. I particularly pasted for you people. Now, can anyone tell, put in your chats what the lady she is walking in the rain may need? I give you a few seconds. Look at the picture. A lady is walking in the rain, and what she may need. Can you put it in the chat box? Saugata, can you just read the answers over there? What she want?
See, the answer goes like this. Shelter, umbrella, right path.
Yeah, very nice thinking.
Raincoat with rain boot.
Okay. Nice thinking. Yeah.
So are you able to see the chat box, Suresh?
No, I can't because I am in presentation mode. No, that's why
Okay,
I
okay.
asked you.
Yeah, okay, okay.
Okay. Anyhow, you are there. My eyes there. So the point is, everybody is right. The point is, it is difficult to understand what he wants. For that purpose only I gave. She may be, requiring an umbrella or raincoat, but at the same time, if you keenly observe, she is crying. Maybe she needs somebody's shoulder to cry. She knows it is raining, but still she is, walking in that. I'm telling, even I don't know what she needs. Don't ask me. But point is, this is how, difficult it is to understand what the customer want. In DFSS, we call this as an empathy interviews and all. So directly you have to do empathy interviews with the stakeholders to understand what they want. See here itself, no, we are, imagine we didn't go to her and ask, and then we took, oh, she wants the umbrella. Then I designed umbrella and go and give her. Will he be satisfied? No, sir. Totally, we did not understand what she wants. She's crying. She needs somebody's, shoulder to weep, cry, whatever it is. Maybe I'm telling again, I'm not sure, but the picture I put it for you people to is to tell you that, sir, it is difficult to understand unless you do empathy interviews and directly ask to the customers. Don't assume in design. That's what is DFSS. You need an evidence. Where is the survey results? You should do empathy interviews. You have to collect the voice of the customer. This is the voice of her, isn't it? Imagine she is your customer, and you want to give some design solution to her. And if you assume that she needs an umbrella and you designed an umbrella and gave to her, she will not accept it. That's customer, voice of the customer, and it is difficult understanding the voice of the customer. Okay. Usually sometimes what happens, whether your engineer and customer, if this is called as good requirement. If you are okay with a particular, say, let's say, door closing effort, you said 15 Newton meters is okay, and customer will said okay, both are happy. Your customer says not okay, but you are also not okay, then it's okay. So it is a good requirement. But poor requirement comes into picture when your engineer says it is okay. Customer says, boss, it is not okay. Customer says, no, as per my standard, it is 15 kg, 15 Newton meters. Then customer says, boss, it is very difficult to close. It is very, more force required to close. I am not okay with that. So when customer is not okay, but you are okay, then you are in a trouble. You are a poor requirement. Okay. And in many cases, what happens, boss, your door is okay. But you say, your engineer says, no, 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 I'm not okay because it is not as per my standard. Your standard customer doesn't understand, sir. That is only your internal standard. So your internal standard is, as per that, this thing, but customer himself is telling, boss, your door is okay. Why you want to unnecessarily work on that? Because it is not meeting your internal standard. So you should understand what is good requirement, what is pure requirement in your major phase. So if you are here, no action taken, then there should have been action. Here is unnecessary work. Customer is telling, okay, don't do anything. But you say, no, 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 I have to change the design because it is not as per my, standards, internal standards. So unnecessary work. So you need to be very careful. And there is one, tool called as Kano model. Kano model, here is the customer satisfaction. Here is the functionality. Three types of qualities are there in Kano model. First one is basic or must-have needs. Here, linear needs are, more the better needs. Here, excitement needs, attractive needs. I will tell you an example. These are untold by customer. This is basic. It is understood. You must have it. And if it is not there, customer will be immediately dissatisfied. I'll give you two examples. Imagine you want to buy a car. You go to the dealership. Will you ever say that, give me a car with brakes? Boss, I am buying a car. Then it means it should have brakes. It is common understanding, isn't it? So this is basic need. Customer need not tell you, but you have to. Imagine one more example I will give you. You want to drink, tea. Okay, you went to the shop or soup. Let's take, you went for a dinner, and when ordering the soup, you will tell only give me tomato soup or a sweet corn soup. You will never tell me that give me hot soup. Boss, when I'm ordering soup, it should be hot only. That is basic needs. You have to work on these, requirements. If you miss, immediately customer will be, dissatisfied. But customer never tell this. These are called as must-have needs. Here, linear or more the better. Example is mileage. Arey yaar, मैं सोच रहा था Alto is giving 15. Arey, it gives 18. Great. Work on those parameters. That is your quality. And one more example, internet speed. I never thought Act can give so much of speed. Yeah, great. This is this. Attractive needs. This also is untold by customer. Basic is untold. This is also untold. Customer never knew that that facility is available in your car. For example, wipers. Wipers, rain sensing wipers. Why I should on the wiper when it starts raining? The sensor should, wiper should sense the rain and then automatically start. Wow, your car, you have given that feature. Customer says, wow, great, attractive. So you work on first on this, second on this, and you have no other choice. You must work on this. So if you divide, your requirements, that's what Kano. Kano is one of the engineers in Japan. He gave this, great, model wherein, quality is differentiated into these three things. Many times, we get, this thing. I will give you one example. I don't want to name the company. See what happens is that is a global company, and they take vehicles from the global and release in India. Okay, same name is also here in India. Okay, global company, and design and everything is done in global technical center, and then brought in over here. One of the vehicles where I was working, we brought one of the global vehicles to India and released it in India. Okay, we started getting problems on the wiper. Warranty is very high on wipers. We were struggling to understand why in India wipers are are high warranty. But if we check in the warranty in the global, in let's say in US, वहाँ उसके ऊपर कुछ warranty नहीं है. No warranty on wipers. Same wiper. Even we imported the wiper. No localization also done. Just imported the wiper and started using in this car. High warranty. Why? What we missed was how customer uses your product. The point here is in India, it is very dust here. They use wiper not only during the rain, but also to clean the windshield. To beginning when you start, a lot of dust will be there on your wiper. So what do? You use wiper and go. But the rubber on the wiper, design was not suited for dust cleaning, because in global, those people don't use your wiper for dust cleaning. They use only during the rain. That is a point. And we miss to understand this voice of the customer. Voice of local customer. Vehicle is same. Wiper is same. Supplier is same. Even we are importing from the same supplier. No warranty in global, but full guarantee, a lot of warranty in India. That was the reason. So just how it is important to know the voice of the customer. It is geographically also you have to think. Don't just blindly, import the vehicle or blindly copy your global design and release the product in India. No, sir. One more example I will give you on that. One of the vehicles, in US, we copied in India. In the sense, we released in India. Same company, global company. In India also, the existence is there. And we released it in India. And India, the vehicle is very costly. More than 20 lakhs vehicle. But in US, that is a basic vehicle. Okay. I don't want to name the vehicle. I don't want to name the company. So in US, owner drive, because it is a basic vehicle, people, not so rich people buy that, and the owners himself drive. So what they designed was front seats with excellent design they did. And the rear seats, not so much, functionality they gave. It is like a bench seat. When we imported in India, when we, re-released it in India, we never, thought these directions, and we just released it in India. So in India, what happens? More than 20 lakh rupees car, rich people can buy, and they will have their chauffeur, driver. So what happened in India? Driver is enjoying an excellent seat, and owner is sitting on the bench seat. The intention is to tell you that, boss, voice of the customer is important, and that you should take care in major phase. I just showed you a lady, going in a rain, and how many voices came here, and what we assumed that what she wants, and so difficult it is. So, okay. The main thing in this thing is, translating the voice of the customer into functional measure and value the relationship. This we already discussed. Again, we use a scientific method as a hypothesis. Like this is the hypothesis. The hypothesis here is, as the pressure increases, customer, satisfaction increases. So you look into that, you put a graph and feel that. This is the other way around. As the time decreases, customer, the satisfaction increases. Whether all the, this is called as, we do clinic. This is, say, your vehicle, and these are your competitor vehicles. Whether you follow a path, whether this is called as a regression analysis in statistics. What is R square value? Required R square value is always 1.0. Great. 0.9 and above. So whether it is running in a path, for example, this is my vehicle. Imagine, this is the force required. Okay. So you measure the force of your vehicle, you measure your competitor vehicles 1, 2, 3, 4, and then you plot the curve and see whether the path is following, whether it is larger the better, whether it is a smaller the better. You have an evidence. Still we are in measure phase. You are measuring the force required, and that is what your project is about. Your project is about improving the door, isn't it? So you measure and look into whether there is a path. So that is called as hypothesis test evidence. Many times we do customer clinics. Customer clinic, it's not your hospital or medical clinic. This is nothing but, imagine you are coming with a new car. Okay. And I want the best car to be designed. So what I will do? So before I go to the design, I do the customer clinics. I make prototypes, give it to the customers. In the clinic, I bring other customers also, other customer vehicles, competitor vehicles also. For example, you are, Maruti, you are designing a new Celerio. Who is the Celerio competition? Its own Wagoner is there, Tiago is there, Quid is there, i10 is there. Bring all 4 these vehicles into the clinic. Let customer use all the 4 vehicles and measure the force required to close the door. Let him do the survey and then rate which vehicle is the best. Imagine, Tiago is the best, taking lowest, force required to close the door. I should be the best, better than Tiago. That is DFSS. You are doing a competitive assessment through clinic and selecting the target of your design parameters. Presently, my door, Celerio door is, 20 newtons, but the best in the segment is 12 newtons. Lower the better. Why I should not choose 10 for the upcoming my new vehicle? If you design this way, what customer wants, what customer is happy about, then your project will be great. That's what you do in DFSS. Many times what happens, customers are not same. You must have observed. Let's take an example of AC. Some people feel 26 is good. Some people feel 18 is good. Then imagine you are a AC manufacturer. What you will give? So this is what is exactly. Customer, some, it's a lever force. Some people feel more than 20 is good. Some people say less than, 10 is good. So 10 to 30, it is varying. Medium or average is 20. So in your design parameter selecting, which you want to select? 20, 30, 10. So you have to think. And we must understand that variation in customer needs. Customer needs also variation is there. I told you AC 26, AC 15. So most customers are you can put a graph over there. This is called a customer loss function. It is one of the tools used in major phase. Put that, and you understand how many customers are happy and how many customers are happy, not happy. So you can do all those things in the customer clinic. What is the maximum acceptable lever force? How much you want to put a design parameter for that? Don't put that last this thing it was 15 newton meters. Okay, it is easy to put 15. I will tell you one example. In my earlier company, one of the thing is ashtray. Ashtray is one of the parameters given in the car facility, right? So usually what we used to do, ashtray last 100 years, same ashtray is being given. Proven design, Six Sigma design. कार में एक ashtray होना, एक that ashtray you copy from that features and put it in design, gone. You don't need to design new. But how many times you have thought whether customer use your ashtray for storing the ash? That is your question in the DFSS. Whether the people are using your ashtray for keeping ash in India. People, while smoking, they open the door and, they open the window and, they smoke. Never use your ashtray for keeping ash. For what they use? Putting coins. And they struggle when the coin andar gaya na, nikalne ko problem hota hai. It difficult to, open the coin. Kept it in ashtray. Think this one. That is called as voice of the customer. And if you don't do empathy, you will again give the same ashtray, which is running in many of years. Instead, you should design a new ashtray which can be used for ash. One of the difficulties in ashtray is how to clean that one. Yeah, you cannot open that and throw ash outside and again bring it in. Instead, you make a separate bin. No. And put the diameter of the bin so high that you can put the coin, your hand will go inside, you can take the coin out. Design that way, your customer will be more happy. Don't put that old Six Sigma design quality this thing in your. This means Six Sigma quality doesn't guarantee you that your customer will be happy. Huh? Quality has to be there, but if you don't give as customer wants, you are out in the market. I will tell you one example. Nokia, let's take a simple. I am not against Nokia. Huh? Don't take me wrong. They started the mobile phone few years back. Touch screen mobile was not there. It is keypad mobile. I still remember 1100 Nokia phone. Excellent. You throw from first floor also. Only the battery gone and then again outside and again refit it. Mobile start working. Such a robust phone. Six Sigma quality phone. But where is that now? Gone. Nokia itself gone. Why? Nokia did two mistakes. One, on the voice of the customer. Customer wanted touchscreen. Nokia never came. Customer wanted Android operating software. Never came. They had Symbiose or something. They said Symbiose is better than Android and they stuck to that. And Nokia closed. Now they are coming into that. They killed Nokia, Samsung, all Chinese, Oppo, Vivo, you name it. And now it is a history. Gone. Why? Is the quality of Nokia phones bad? No. Six Sigma quality, excellent quality. But they did not give what customer wanted. Customer don't buy, sir. If they are not satisfied what they want. And this is what you have to think in your design. I told you ashtray. Does customer use your ashtray? If yes, then fine. Otherwise, please check. You should have an evidence. So house of quality, we have already talked about. This will be the out of major phase. What is the voice of the customer? It is difficult to use the door. What are your functional measures? Force required to close the door, weight of the door opening angle, position of the handle, hinge torque. What is the unit? What is the target? What is the testing method? So with this, your major phase will be done. So this table is the output of your major phase. Next is analyze phase. Most interesting phase. is analyze phase. Analyze and come out with a different concepts. So ideas you have to generate. Beautiful from Swami Vivekananda, I got it. I just put it here. Every new idea is a joke until someone achieves it, and every thought is silly until you try it. Swami Vivekananda mentioned this. Perfectly suited for DFSS analyze phase. I took it from Swami Vivekananda sayings. Great. Unless we are human beings. Resistance for change. Resist change management and so anything new comes immediately we resist. Alright, we are engineers, only ashtray. For ashtray, technically ashtray, bus. Think different things. Come out with different ideas. Out of box thinking is all comes in analyze phase. And adults are poor in idea generation. Adults are poor in idea generation. Especially engineers are more poor in idea generation. Why? Because we have been tuned by ISO system processor, and because of that our vision is like this. We cannot think out of box. Very difficult. But kids, go to your home, ask your son, he gives better ideas than you. Out of box thinking. Feasibility, I'm not talking about here. Getting different ideas. Idea generation is very difficult for adults than your kids. So what you have to do? Generate ideas, many ideas, and then select one idea for your design and development. That is analyze phase. Collect the voice of the customer, identify the CTQs. CTQ means critical to qualities or special characteristics. Develop different alternative solutions. Boss, one thing you remember in this world, there is no one solution for any problem. There will be multiple solutions, only we don't think. We think this इसका मतलब यही है और यही answer है. That is human beings. Develop alternative solutions, build knowledge of product, think out of the box, trade-off analysis. Then you do, which is the best one. But out of box thinking is very much a small creative exercise for you. Again, 1 minute job. This is what it is, a paper clip. List as many uses as possible for a paper clip. And let's do only one job. So it is 4-4 now. And you put your answers in the chat box. How many ideas you got? 1 minute. You just list down your ideas, how you can use your paper clip in different ways. This is exercise I do for idea generation, and out of it is. I hope you are doing, and you have to put it in the chat box. And Saugata will read me at the end who has got how many ideas. It is not to test you, let it be silly. Just be open. How many ideas you got it in 1 minute?
Shiva Reddy has written keychain.
Okay. Number they can write. How many numbers they got it?
Somebody has written 4.
Okay.
The examples are daughter's hair clip, replacement of button. Naresh has written 5.
Okay, done, sir. 1 minute. Who has got maximum? Anybody crossed double digit?
No, 5 is the max till now.
See, sir, how difficult it is to come out with a new creative use of a paper clip. And if you are an engineer, you calculate ideas per minute. I have given 1 minute, means your IPM is 5 max what you got. Nobody got 30 ideas per minute. Anyone? No. Why? Because your brain, it is difficult for us to think out of the box. Maybe you go to your house and your son will give better idea using these clips than you. He can give more ideas than you. I'm not blaming you people. I'm telling you, we as human beings, Ideas, new generation is tough. And ideas, you know, you don't know when the idea comes. You cannot use any process to bring the new idea. You follow step 1, 2, 3, 4, 5, you will get 10 ideas. No, this is brain. Brain has got left brain, right brain. Left brain thinks about, you know, all analytical skills and right brain is all emotional, these things and all. We use left brain more than your right brain. So you have to go out of the box thinking and come out with different ideas. And only these will solve the issues now. When we were working in the organizations, there was no department called as innovation department. Now the big OEMs are coming out with the innovation department. Do you know, in my one of the earlier companies, we had an innovation department. Avishkar naam diya tha humne, Avishkar. Okay, I don't want to tell the company name. And what will be there inside the innovation department? There will be innovation manager, there will be innovation engineers. Their job is to come out with the new ideas. Boss, if you want to sell your product, if you want to stay in the market, if you want to grow in the market, you have to come out with the new ideas. Look at iPhone. Why iPhone is so famous apart from brand value? Look at the features they are bringing in. I still remember when Samsung came out with mobile, 1 GB RAM mobile, 1.5 GB RAM mobile. Anyone who has got 1 GB, 2 GB RAM mobile now? No. Minimum 8 GB mobile. And I saw OnePlus releasing 16 GB mobile, 1 TB hard disk. And within no time, your mobile becomes obsolete. You can't sell mobile for 4 years. Gone. 4 months, new mobile has to come. Otherwise, you won't stay in the market. You are gone. And your creativity, your innovation has to work on that. And that's what I told. Many companies are coming with the innovative, things. There are so many ideas in the, creativity thinking, brainstorming, brute thinking. Couple of ideas I will tell you. This is my favorite idea. Brute think. Look at that picture is my favorite picture. I imagine he is a commander. He believes that only war is done with the sword. And these are say trainees. They have brought a beautiful fighting equipment like this one. He is not ready to look at that also. He says, I can't be bothered listening to new idea. We have to battle the fight with sword. Resistance for change. This is where company needs fresh blood. And this guy is not making new connections is tough. Brute thinking is you are working on parking brake lever. Go out of the box. Forget parking brake. What your brain knows, take a word, tree, water, air, and then list down all the characteristics of that and then come back to your problem of parking brake. How these words are related to parking brake and come out with that is called as brute thinking. Double reverse. Many times our brain thinks, better in a negative way. For example, door closing effort. First, you think that how I can make worse to my customer. Same problem. You make it worst. How I can make worst to my customer. Immediately ideas flash हो जाएगा आपको. Door increase करो, handle hide the handle. Your customer should be further frustrated. Bring the ideas that way. List down all those ideas and then reverse those ideas. That is called as double reverse. And you get beautiful solutions sometimes there. It is not a big tool. Just think in a negative way. How I can make this worse to my customer? Reverse of that will become the increase the door weight like anything. Decrease the door weight. Hide the handle. Make the position of the handle good. So these are the solutions you are getting. Directly, if you would have thought, you might not have got. But double reverse is one of the solutions. Tridge. Tridge is a separate training itself. It's a creativity technique. It is a Russian guy who invented Tridge. It's a creativity technique. And one of the Tridge technique is contradiction table. There are 39 engineering parameters, columns and these things, and 40. And the cross section, you have the solution. What is the problem? What is the problem? And for that problem, this is the solution. It's a contradiction table, one of the Tridge techniques. And some separation techniques, contradiction tables are there. For example, Coke. Earlier, the design was like this here in the top. They made the design like this and they reduced the thickness. So That's what the Tridge technique they used. Separation principles are there. Time, space, and scale. Needle example, beautiful example is there. For example, you want the needle of the eye of the needle to be big and small, both. You want both. Where only time differs. Only while inserting the thread you want eye big, but while seeing you want small. Same hole, huh? You want big, you want small. Contradiction, right? So how you to design? So you design a needle with two needles, small needles welded together and rotate, quarter and then, weld on the other side. So when you are inserting the thread, you rotate clockwise, insert the thread, leave it. It goes and, this becomes small. This is an idea. And this is Six Sigma. This is DFSS. This is your analyze phase. Come out with different ideas and to solve the problem. So this example I have already told, and there is a PO analysis. PO analysis is basically a decision-making tool. There are performance criteria, business criteria. For example, you want to buy a bike. So all the performance criteria you take, all the business criteria you take, like performance criteria, what is the HP of the motor, what is the aesthetics, what is the RPM, what is the weight, all those are the performance. Business criteria, cost, one of the thing, cost, time, risk. For example, your son, you want to give a bike. So cost is my CTQ, boss. I can't spend more than 1 lakh. That's my CTQ. So you identify the CTQ and then you rate and then you decide the best solution. So your analyze phase is basically come out with different ideas, come out with different concepts and select the best concept. Next is design phase. Very simple. You design and develop and optimize. So design and develop, I don't want to, elaborate anything more here. It is basically design and development. And what are the steps involved in design and development? Design planning, design input, design controls, design output and changes. Basically a design department, what it does, right? So that is, you exactly do. So what design you will do? Which concept finalized here? You go into development of that concept. That is called as design phase. Okay, so these are different planning activities. These are the inputs required for your design. These are the controls required like design reviews, all those things, design verification and all. And these are the output of your design. Meet the input requirements. Outputs are adequate. Monitoring and measurement activities, product characteristics, CTQ dimensions. You know how to select CTQ dimensions in design? There are 3 F's in that. Fit, form, function. Any parameter which is affecting the fit of the assembly, the form of the assembly or component and function of the assembly or component and safety. So these 4 parameters always decide your CTQs in Six Sigma. CTQ means critical to quality. Design and development changes, design changes and all your EWOs, all those things, becomes your design changes. So with that, you design your part, whatever, you have, identified as the final concept, and then you go for optimization. Optimization is nothing but in presence of noises, how your, component behaves. For example, this is US and LSL, and this is one graph you are getting, and this is one graph you are getting. Which is better? This one, no? Because variation is less here. Variation is very high here. So noise factor effect on the performance is weak. In presence of noises, there is less variation in this part. So it is say brake pad B, brake pad D. Which is better? Brake pad D is better. Why? In presence of these 2 noises, the variation is less. And this is for brake B, pad B. So in presence of noise, the variation is very high. That's why your distribution curve is coming like this. It is going out of your USL and LSL. So which one you will choose? You will go with pad B, right? So what is optimization is induce the noises. And I told you noise means the factors which are not in your control, like temperature, humidity, customer usage. So you induce that one and then you test and select the best one. That is called as optimization. You have to optimize your design. There are some formulas for optimization and all. You have to calculate S by N ratio and all. I'm not going to confuse you with you all. So you can use softwares for this, and you calculate the S by N ratio, and that becomes your robust assessment measurement. And you have to do many error proofing in your design. Particularly, two pictures I have brought for you. Simple. Imagine you are a stove manufacturer and you measured, you designed the stove like this. These are the 4 stoves, and these are the 4 knobs here. Imagine you release it into the market. Customer gets confused. Yeah, this one is for this, or this one is for this, or this one is for this. क्या design किया है यार? Who has designed this? Which idiot has designed this? Customer will, you yourself will scold the customer, designer like that. So because it is not easy to customer. You are an engineer, by your hypothesis theory that this is for this. Customer is not an engineer. So make him very easy. Imagine instead of that, you design the stove in this way. These are the 4 burners. And you have placed the burner knobs in a circular like this. Now it is natural mapping, sir. This is for this. This is for this. This is for this. This is for this. How much time is required for you to design this way instead of this way? Think from customer usage point of view, whatever you design, that is DFSS. If customer word is not there, then it is not at all DFSS. Imagine if you have designed your stove like this, nobody is going to buy you, or your customer, you are going to get the beating. One more, a simple door. Okay, if the door is like this, then that there is a handle, it is coming outside. You are standing here and it opens outside. And if it is a plate here, that means it pushes inside. This is natural mapping, right? So handle means it comes out door, push means door goes inside. And if you design door like this and leave it, now customer comes there and अरे यार ये push है या pull है, hinge यहाँ है या यहाँ है, किसी को पता नहीं. Isn't it? So as a designer, use some error proofing. Pokayoke is the word, they use this thing. Use error proofing in your design. So that is DFSS, Last phase, few minutes I'll take for the last few, and then 10 minutes I will show you one project. Verify phase. Verify phase is nothing. Whatever you have designed, okay, verify that it meets the requirements, it meets the goals and objectives defined in your defined phase. That's how it is a cycle. So verify means you verify that the design what you have done in the earlier phase meets all the goals and requirement done in the verify phase. Let's take one example. You have taken a project of mass reduction. 30% mass reduction is the goal you have defined in defined phase. Now in verify phase, go to defined phase, just see that whether you have achieved 30% mass reduction. One thing you remember, it is not mandatory that whatever you have mentioned, it must be verified. For example, you took 30% stretch target, but you achieved a 20% reduction, mass reduction. That's fine. कुछ भी नहीं था यार, आपने 20% improvement कर दिया. It's fine. I have taken stretch target here. Don't think that if I don't do verify 30% mass reduction, my project will not be closed. That is wrong. Your project will be definitely closed because this is a stretch target, and definitely you have done an improvement here. This was a guess. Okay, I will take 30% improvement. I will take a 50% improvement. Because you're still in define phase, you have not solved the problem. But in verify phase, you verify, and it's okay if it doesn't meet the exact difference. So one word comes here, in verify phase is verify and validate. I don't know whether you people know the difference between verify and validate. What is verification? What is validation? I will tell you a beautiful example here. Verify means your output should meet the input requirements. Validate means it should meet your design intent. That is validate. Validate always is linked to the test. Validation test जो हम बोलते हैं ना, this is test, this is output by input, whether it meets. I will give an example. Imagine you are a pen manufacturer. Okay, So pen has got a nib, cap, body, some 5-6 parts. You give it all the suppliers. Supplier will manufacture all the parts for you and give you only assembly is your job in your plant. You are assembling pens. So you had released the drawings of all the parts. All the parts came. You checked all the parts, sub-assembly parts, components as per drawing. So what you are doing is a verification. The input is your drawing, the output is your physical part, and whether the physical part meets the drawing, that is called as design verification. What is design validation in this case? Design validation is finally when you assemble all the pen and put the ink, pen should write. There may be a case that, all parts are as per drawing, but pen don't write. Possibly. So validate is meeting whether checking whether your part or product meets the intended design. What is the intended design of your pen? Pen should write. So that is validate. So you must be very clear the difference between verify and validate, and that is to be done. The name is verify they have given here, but you should verify and validate. For that, what you do? You should have a plan, measure the performance, and then you do it. So verify is nothing but what objectives you have taken here, and in measure phase also you have functional requirements measured. No, for example, we took the voice of the customer as door closure, and what are the functional measures we took? Weight of the door, hinge force, torque, position of the handle, all those things, and there were targets if you remember. And how to give targets? By doing clinic, I told you. So those, for example, the force required to close the door, you have arrived at the target 10 Newton. Verify here when you designed a new door, verify that it takes only 10 Newton meters, less than 10 Newton meters. So verify has got two links: define phase, measure phase. In define phase, your goals and objectives are there. Verify that they have met. In measure phase, you have functional measures. Verify that these functional measures are met. That is your verify phase, nothing else. So it is meeting the goals. And we already talked about verification and validation. Don't want to go deep there. And this is how you have to show in your project report before, after. Before, this was my variation, and I took a DFSS project, and now this is my variation. Given project's objective, you prove that you have improved, and this you have to tell before and after. That should you give in verify phase, right? So in after verification, there may be change in SOR, statement of requirements, or standard operating procedure, best practice. All those things may be there in the verify phase. Okay. With that, I complete my training or my webinar on overview of Six Sigma. I cannot make you Six Sigma expert, but you should know what is DFSS and what you should do in each of the phases, DMADV. So now I will show you one sample project. One disclaimer here. This is one of the projects done in my earlier company. I have hidden all the confidential information here. Don't ask for what is that value, how much that value, and all I have hidden. And I have made masked so that confidentiality of that OEM does not affect. Okay. So this is one of the projects done in a DMADV for in one of the OEM automotive. Reduction of end gate hardware for strength and slam tests. So this is the end gate car backside, the last dicky, what we say now in common language. So they were designing this door, and for that prototype building they used to do some 14-15 cars they have to do and test. Okay, and then validate the design. So they took a DFSS project. Instead of 14-15 physical tests, they did some virtual tests, and they eliminated these tests. That is the project about. They use DMADV, right? Project owner's name is there, sponsor name, mentor name, MBB name, all those names you should mention. And this is the title of the project: reduction of end gate hardware. I'm telling you, this is how the project should be done. And there will be project reviews done by sponsor and coach. what they reviewed, which date they reviewed, all those things will be mentioned in the change history. And project background. I told you the project background. They were, using 15 physical hardware tests to prove the verification. But they took a DFSS project and virtually they did CAE analysis and they avoided these post. So when you avoid a physical test, a lot of saving is there, no? Because in physical you have to build it and then test it. Instead, you do CAE analysis and then use your CAE analysis results to prove that this design will meet your hardware test results. That's what they're proving using CAE analysis. So you can give the project background, give all the pictures about what your project is about, give all the data presently, how many physical tests are being built in that company, give all the data in the project background, and then come to define phase. Define phase has got input and output, and this is what is required in the define phase. You launch the project, scope of the project, goal and outcomes of the project, who are the stakeholders and team, what is your CTQs, and what are your controls. So this they are in define phase, and they are writing what are the inputs and outputs of their project. And then this is their project charter. You can see here what they want to do, what is the goal of the project, what is in scope, what is out of scope, what is the goal statement. Look at that, to reduce end gate hardware by 70% by end of April 23. So that is their goal statement. And problem statement, I told you in detail, they will write here. So this is called as project charter. And then they come to who is the lead, who is the coach, who is the champion, and then what is big why. See, in Six Sigma, I forgot to tell you, always Six Sigma is, works on the function called as Y is function of X. Y is, dependent function. X's are dependent, Y is independent, X are dependent. X is depending on Y. Y equal to X1 plus X2 plus X3. So you identify what is your dependent function, what is independent function, and give the big why. What you want to achieve in the project? You want to reduce the hardware by 70%. You avoid the cost by 70%. So that is their big why. So what they want to achieve in the output of their project. And this is the timetable like DMA, DV, when they want to start, when they finish it off. That's a project report I'm showing you. And this is the voice of the customer. Capture the voice of the customer. It's very important. I told you, I should also told you that how difficult it is to understand the voice of the customer. Bring all those things, do surveys, do all those things, capture the voice of the sympathy, empathy interviews. I told you, empathy, voice of the customer, JD Power survey results. Take all the inputs in your project because you want to do a robust, design in your project. Then you come to measure phase. Measure phase output required is what are the functional measures, and they are translated from your voice of the customer. Identify the customer, determine the current state. Where are we now? 14 or 15 tests are required. Development a research plan, translate this into product requirements, and identify the targets. So this is their, functional requirement. Hardware samples 14 were there. Baseline. Baseline means presently how many tests they are using. 14. You want to reduce by 70%. That means only 4 samples you do the physical test. Remaining 10 you use CAE analysis. That is the project is about. Right? You give all the requirement about your projects. Prepare a functional diagram. What is your input? What is your output? What is the process? So that you functional diagram you prepare, and then you have parameter diagram. Parameter diagram is one of the requirements in measure phase. You have the system here. What is the input? What is the output? What are the control factors? Control factors means design parameters. And here are the noise factors. Noise factors, I told you, the factors which are not in your control, but they affect your output, like temperature, humidity, customer usage. So these are called as noises. So that is called as parameter diagram. It is input, what is the process, what is the output, design parameters, and noise parameters. So that's what they did. They came to analyze phase. And they came out with the different ideas, analyze strategy, how they want to do it, what is the CA analysis, what factors they are considering, material variation, thickness variation, load variation, bar position, friction, etc. So this is a pure technical design project I'm showing you. And then, you have the issue analysis, what is the variation study, field issue, customer complaints, everything they are presenting in their report. There is a process flow diagram. I don't want to go in detail about that. So you get through, in detail about your project. And then one more thing beautiful they have done is DOE. I don't know how many of you understand DOE. DOE is design of experiments. Okay? Design of experiments. So there will be 100 numbers of runs. I request everyone to mute, please. Request everyone to mute. Yeah. Okay. Then you identify what are your variables. Okay. In running a DOE, design of experiments itself is a big training. Huh? It's a 2 days training. So you identify your design parameters. Basically in DOE, what you do, what is the specification of your design you are arriving at. For example, you want to arrive at 10 mm or 11 mm or 9 mm. Optimize your parameters. Optimizing design parameters is done in DOE, design of experiments. Okay, there will be number of runs, and one of the methods what we use in DOE is Taguchi's dynamic response method. There is L18 array, L9 array, L12 array. So many things are there. Don't worry all those things now at this moment because you are in overview. Just understand that DOE is for optimizing the design parameters. And that's what they have done in this project. I don't want to go in depth. So this is, and you can see with pictures, they have brought in what are the design parameters. And then this is, 256 runs. Runs means it is like a recipes. Imagine you want to make a tea. What are the input parameters for tea? Tea powder, sugar, milk, all those things, right? What combination you have to use? Whether I should put one spoon tea powder or 1.5 teaspoon powder, how much cc of milk I have to put, in cc, I will use 10, 20, 30, and then I will use, sugar, 1 spoon, 1.5 spoon, 2 spoons, then combination of all those things and which is the best recipe. So if I put so much cc of milk, so much of spoons of sugar, so much milk powder, I will get the best tea. That is design of experiments for tea making. And that's what is done here. DOE runs different tests, you conduct and then select the best, design parameter. So Monte Carlo analysis simulation is there. A lot of technical project, very in-depth, study we had done. Probability theory we had used in this. One of the excellent projects. And then they came for design. Design is nothing but CA analysis design they want to do. Okay. Design interpretation of DOE results. Then they came to verify phase and then verification plan they did. And finally they, I have put it here only 96% of the target. I have removed the values because it is confidential to the OEM. So I just put percentage, nobody understands. 43% they achieved, 96% they achieved, 8.5% they achieved. What was actual, what they achieved, exact numbers I have removed and I put, only percentages. But when you do the project, you can put the exact number. Okay, so this is just to make you aware that how a DFSS project look like. And now they reduced from here to here, before and after, right? Before and after of hardware properties. And this is their SOP, standard operating procedures. And this is the deliverables, summary of their project. And this is the cost benefit analysis, how much, cost they saved by doing this project. And there should be an approval required. And by sponsor. Sponsor should say that, yes, this completed project solved my issue and, improved my this thing. And you can get, approval from your global counterpart also. And this is a project closure note. This guy did a great job. He reduced from here to here. We don't give numbers here. We give only percentages and all. So, yes, sir. With that, I complete my webinar overview. And now I will go to, question answers and summary. I will just tell you the summary. 1 minute. Yeah. The summary is Six Sigma. We started with the overview of Six Sigma, right? A lot of statistics is involved in that. But the main important point that there are two types of DFSS, Six Sigma project, DMAIC and DMADV. And today's topic was on DMADV, DFSS project. 5 phases: DMADV: define, measure, analyze, then design and verify. So I give a lot of examples. I did small exercises with you all. So I hope you enjoyed my webinar, and hope you got some value addition about Six Sigma compared to yesterday. Today your knowledge increased by so much. First of all, thank you for listening for 3 hours to me, and thanks especially Saugata, to allowing me to talk on my favorite subject. And I hope I have done my job. And thank you all. And now the stage is yours. You can ask questions. Saugata.
Uh, Thanks a lot. Thanks a lot, Suresh. So what I'll do, the people who have raised the hand, I'll just move them to the presenter. They can, so that they can speak out also. First, is it Colonel Mahesh? Okay. So Mahesh sir, you can ask a question now.
Whether they will be able to speak, Saugata, or they have to write only.
Now I'm enabling. So yes, they will. So Mr. Palak Tiwari, do you have any question? You have raised the hand. So whoever you like to ask any question, kindly raise your hand, and I enable you to question. So the comments are like this. I think Suresh, you can read out the comments. Excellent session. We need more session related to design FMEA.
Oh, thank you.
Okay, so you can put your question back over email or things, and we'll try to see whether we can cater those requests.
Sir, can I ask one question, sir?
Yeah,
Your
sure.
name?
So myself, Vishal Tiwari.
Yeah.
Sir, from IIT Roorkee, sir.
You okay?
Sir, there are two questions from my side.
Okay.
Sir, often we see the concept of 7 Sigma.
Yeah.
Sir, the 7 Sigma takes the quality optimization to the next level by
Correct.
further minimizing the process variability and
Correct.
enhancing the reliability.
You are right.
Sir, whenever we are hearing about Six Sigma,
Yeah.
often we see the bell curve, which is an asymptote to the x-axis
Correct.
and touches near about the perfection level up to the 99.999 and 7.
Yeah,
So,
you're
sir,
right.
it is near about the 100% perfection.
You're right.
What we see is 3.4 defects per million.
Correct.
That is the basic concept of the Six Sigma process.
You are right.
So, sir, if we are having this much level of perfection with the Six Sigma, then
Yes.
what is the need of having the 7 Sigma concept? Because it is saying that it is reducing some more variability. Sir, उस level पे जाने के बाद मेरे ख्याल से कोई